every day, on this planet and beyond.
Since the dawn of time, mankind has sought an answer to an undying question. Are we alone? Now, humans possess the technology to solve this mystery, and we will shift their gaze to the stars. This is the search for exoplanets. This is TESS.
From NASA's Kennedy Space Center in Florida, you're watching live coverage of the Transiting Exoplanet Survey Satellite, or TESS, a mission to find new planets outside of our solar system that could support life. Hi, I'm Marie Lewis. Thanks for joining us. TESS will help us answer an age-old question. Are we alone in the universe? The images TESS will capture could be the key to solving the mystery. TESS is a planet hunter, about to embark on a 2-year mission to scan almost our entire sky by breaking it up into 26 different sections. Powerful cameras on TESS will stare at each zone for about a month, monitoring more than 200,000 stars and looking for changes in their brightness that signal a planet crossing over. Our goal is to find other planets like Earth and decide which ones deserve a closer look. SpaceX edits from launch, so let's check in with NASA's Josh Finch and Mike Curie in Kennedy's Mission Director Center for a weather update. Guys?
Thank you, Marie. I'm Josh Finch.
And I'm Mike Curie, and we are in the Mission Director Center in Hangar AE on Cape Canaveral Air Force Station, very close to Space Launch Complex 40, where the Falcon-9 rocket is poised for launch today. We have teams from SpaceX, NASA, and the U.S. Air Force working from the east coast of Florida to the west coast of California to launch NASA's planet-hunting spacecraft. Our first launch attempt on April 16th was scrubbed to allow launch teams to further review data for the SpaceX Falcon 9's guidance, navigation, and control system.
Weather for today's launch, and the forecast has improved as well from our first attempt. Today, the skies are clear, as you can see on your screen. The temperature is about 72 degrees, with light winds out of the southeast at about 10 to 15 miles per hour. We have no primary concerns for launch today. Our probability of violation is less than 10%, meaning we're over 90% go for today's launch in terms of weather.
The U.S. Air Force is also monitoring the eastern range to make sure commercial and personal aircraft are clear of the restricted area and that waters within the launch safety zone are clear of any boats. We also received a collision avoidance update, which is tracking any potential objects in space. It's all clear for today. We have no so-called COLAs, so we're on time for the opening of the launch window.
Teams continue to work through the necessary procedures to prepare the Falcon-9 rocket and the TESS spacecraft for launch, including loading fuel into both rocket stages and making sure all systems are properly checking out. As Mike mentioned, we've done collision avoidance with the Eastern Range, a checkout of the autonomous flight termination system, and the loading of RP-1 fuel, our rocket-grade kerosene, began at about T-1 hour 10 minutes. The Eastern Range confirms that it is go for launch of the Falcon 9 and the landing of the first stage, and liquid oxygen began being fueled at T-35 minutes. So with weather a go and things tracking on time here, Marie, will go back to you.
All right, thanks, guys. This is not the first time NASA has explored the possibility of other Earths orbiting distant stars. The missions of Kepler and K2 have found thousands of known and likely planets that forever changed our understanding of what lies beyond our solar system. TESS, a joint mission between NASA and the Massachusetts Institute of Technology, will continue this groundbreaking work. But TESS is different from Kepler in two important ways. First, TESS will cover an area of sky 350 times larger than Kepler. TESS will also look at stars up to 100 times brighter than those Kepler studied. This will show us planets closer to our solar system, making follow-up observations much easier. Using TESS data, missions like the James Webb Space Telescope can hone in on specific traits of these planets. Are they water worlds or perhaps big rocks like Earth? And could they support life? Scientists expect to find about 300 planets the same size as Earth or up to 2 times larger. TESS will be the first launch of its kind for SpaceX, and NASA is proud to be expanding our range of missions with our commercial partner. SpaceX's Brian Malstedt joins us live from their Mission Control Center in Hawthorne, California with more. Brian?
Hey everybody, my name is Brian Malstedt and I'm a software engineer here at the SpaceX headquarters in Hawthorne, California. Now, it is not every day that you can say you're launching a planet hunter, So today we're all very excited to launch such a cool spacecraft. Now most of you have probably watched our launches to the International Space Station, or the ISS, but the profile of today's mission is quite a bit different. For our resupply missions to the ISS, Falcon 9 delivers Dragon to a low Earth orbit at around T+14 minutes, and then Dragon makes its way to the ISS about a day and a half later. Now for today's mission, Falcon 9 will be delivering TESS to an elliptical Earth orbit, from which TESS will then move on its own power to its final lunar transfer orbit. Now that mission profile just described is much like more of our geosynchronous transfer orbit missions, or our GTO missions. Now after separating from the first stage, the second stage will coast for about half an hour, with the deployment of the TESS spacecraft at about T+49 minutes. Now today TESS is flying on a new Falcon 9 rocket, but we are planning to land and recover the first stage booster after today's launch so that it can be reflown on a future SpaceX mission. Now for this mission, we will be attempting to land on our autonomous spaceport drone ship, affectionately named, of course, I Still Love You, and we do hope that the signal holds out long enough so that we can bring you live video of that landing attempt. Now the drone ship is currently stationed out in the Atlantic Ocean, waiting to welcome the first stage back to Earth at about 8 minutes after liftoff. And remember, landing the first stage is the secondary objective for today's mission. Our primary objective is to deliver TESS to orbit, and so far things are looking great for an on-time liftoff at 6:51 p.m. Eastern Time. Back to you, Marie.
Fantastic. Thanks, Brian. TESS is decked out with impressive equipment to carry out its mission. 4 spinning wheels allow TESS to turn and point at specific stars. 4 state-of-the-art cameras will look for changes in light that indicate a moving planet. Each camera has 7 stacked lenses to bring images into focus. A shade protects the cameras from the sun's heat. A computer inside TESS stores data, and an antenna transmits that data back to Earth once every 2 weeks. Now, interpreting the data is just as important as gathering it. NASA's Amanda Griffin is live at Kennedy's Turn Basin with TESS program scientist Dr. Martin Still with more. Amanda?
Thanks, Marie. Dr. Still, thanks so much for joining us here today. Can you tell us a little bit more about these exoplanets that we're hunting?
Sure. Our solar system has 8 major planets, including the Earth, of course, and they all orbit our sun. If we look at stars elsewhere in the galaxy, they also have orbiting planets, and we term those exoplanets.
And so how is TESS helping us study those exoplanets?
If you can remember, the Kepler mission is still operating, and its task was to determine how common planets were in the galaxy. And the answer is they're everywhere. They're all over the place. So that allows us to build and launch TESS and do a survey for the nearest planets around the nearest stars. Now, Kepler, because of the nature of its survey, while we're all excited about the planets and the planetary systems that it found, you'll notice that there was not so much, there's not so much of the story after the original detection, because those planets are so far away, we could not follow up and do more science. With TESS, these stars and planets are so much closer that we can then characterize, we can find atmospheres around these planets, characterize the constituents of those atmospheres, so we'll be able to do follow-up, and so the stories of these planets will continue on long after detection.
And so why do we care about these exoplanets?
Because it's our human nature to understand what the universe is. It's our human nature to understand where we came from, where we are going, and of course, are we alone? And the only place in the universe we know there's life is here on Earth. And so the most natural place to
Understand that you're looking for at 85% of the sky. Where's that other 15%? Why are we leaving that out?
Oh, sure. It turns out that we're already surveying that 15% with the repurposed Kepler spacecraft right now. So we're saving our own time and energy to survey brand new parts of the sky.
Perfect. Well, good luck with today's launch, and we look forward to seeing what TESS brings back.
Thank you very much.
Back to you, Marie.
Thank you, Amanda. You're looking now at a live view of Space Launch Complex 40 at Kennedy Space Center in Florida with NASA's next